So I'm James Mason. I'm a developer at SUSE and an openSUSE community member. I'm currently working in public cloud.
Yeah.
And
I'm Richard. I'm a QA engineer at SUSE and chairman of the openSUSE project.
And we're going to talk about making the leap from development to production with openSUSE Leap. I'm going to tell my phone to not bother me for an hour. Okay. Developers, are we all developers here? Raise your hand if you've never written code. Okay, that's good. Okay. In the experience of developing code, you're going to develop in one place and you're going to put it in production somewhere else. It's very rare that you're going to take your laptop with your source code and say, hey, everybody come access it. You're going to move into a production environment and it's going to be different than your development environment. Not just your debugging tools. You're not going to have your IDE. You're going to want to strip away as much surface area. A production server, especially out on the internet, has a lot of attack surface, and you guys know this, right? This is common sense. But you still want to keep your dev environment in line with your production environment. I mean, that's just common sense. Because if you don't have a dev environment that lines up with production, then all kinds of stupid bad things happen that could very easily be avoided, right? But parity is coming.
So the question, we've been spending a lot of time thinking about this, and why does this problem exist? And it really boils down to the distributions, the platforms which you have as an opportunity for you in production, very rarely match what you're actually using for development. I mean, if you're thinking in terms of enterprise versus community distributions, your typical enterprise distribution has significantly less packages available than a community distribution. Like RHEL is about 2,500, SUSE Linux Enterprise is about the same, whereas those community distributions will have 8,000, 10,000 source packages, so a lot more binary packages. That's what you're going to be wanting to use in production, in development. So, I mean, to put it bluntly, user space applications in enterprise distributions suck. They're not there. You haven't got them, and if you're lucky enough to have them, it's the ancient version from 20 years ago, which doesn't run your latest version of Python and Java and whatever you actually want to be developing against. But you need those user space applications to do development. And this is the crux of the problem which we're all facing every day. And whenever we go to anybody and say, what's the solution? The answer ends up being containers.
Raise your hand if you were just going to shout out, but Docker fixes all this for me, right? Okay. Docker does not fix this problem. And I'm going to go out on a limb and first tell you that SUSE has been supporting Linux containers for 14 years.
Yep.
Since
LXC,
Linux 10.
Straight from day one. Yep.
Right. Okay. So this isn't something that we've just been dabbling with, playing with new. This is like forever old solution to the problem. There's security issues, certifications. Don't even get me started on the certification thing. But fundamentally, the real issue with Docker is that the way Docker is handling Docker is a mess, right? And so, and I say that in all honesty, we're trying to come up with some good solutions. SUSE is moving towards some great solutions to these problems, but the way you run Docker from Docker, the way Docker wants you to use Docker is a disaster. And I'm going to give you an example, because I say that and a lot of people don't believe me.
But just before you do, even with this example, even if there's a solution for this example, quite often you go to a container guy and you ask this question of okay, how do you fix this? And they're like, oh no problem, the developer will take care of it. You need that new library for that security issue. Yeah, they just package a new one in and push out a new container. It's you're still stuck in that fundamental dev versus ops battle, even if you fix this issue that James is going to go into.
So this is not a particularly contrived example. This is a pretty reasonable example. Let's say you want to run WordPress with Docker. Does this sound like an insane situation? Okay, this is the Docker file that generates WordPress. It's on GitHub, okay, and this is really impossible to read, so I'll highlight a few problems here. The first thing I really see is that the first thing you're doing is curling the tarball from WordPress.com, right? Does your production server have the ability to? No, probably not, okay? You're going to be doing this. What if your internet connection is down? You cannot make a new container, right? What if WordPress is compromised? Okay, so great. That's lovely, The other thing is that this is relying on another Docker container, because Docker likes to nest. So it's relying on this PHP 5.6 Apache container. So what does the Docker file look like for that? Whoa, that's complicated. Do you think you know what all of that does? Probably not. There's a couple things in here that annoy me too. We do this again. First of all, PHP is being built in the container from a fresh version of PHP every time. It's not using a package that's been vetted by any distributed vendor. It's pulling it in and it's making and compiling. So one of the things that's happening up at the top there is installing GCC and its entire dev stack in your container, right? Should you have a compiler in a production server? No, because then all somebody needs to compromise your server is to be able to put a string of source that they can compile into a binary and run, right? If you only accept binaries, it's a lot harder to get a binary into a production server than a string of text, okay? But this in itself is not the end of the road. This is based on Debian Jessie. Well, that seems like a great place to start, right? Debian's solid, right? Well, the Debian Jessie image in Docker Hub comes from this guy, comes from here, right? This guy Tienen. I don't know who he is. He's definitely not Debian, right? But this is the Docker file. And I don't even need to zoom this in, because all it says is from scratch, add this tarball to the root and run bash. What's in the tarball? What if there's a problem? There's issues on Docker Hub, right? So you'd know if there's a problem, but he doesn't use them. He maintains them in GitHub. And there are open issues with this Debian Jessie base that the Docker image is built on. So now you've got a Docker container that's compiling GCC, running GCC to compile PHP, and then downloading WordPress from a website, assuming that no DNS has ever been compromised ever, to build this giant container to run from. So when you have something like Ghost and OpenSSL needs to be patched, who did it? And who's responsible for it? How do you know that this stack is fixed? You don't, right? There's like no earthly way to know that this was actually patched and maintained. And so right there at that point, you got to say, this doesn't work. This is not giving you a good foundation. And there's another guy that's giving a talk on why Docker sucks, and he'll go more into that. And if you want to come to the Q&A, or if you want to talk Q&A more, we can talk about some of the things we're doing, but just to the point of saying that for this process, the way Docker wants you to work is not an answer. So part of the answer is packaging. And part of the answer is distribution packaging, and I think it's really important because it solves a lot of these problems for you. And when we take a package in SUSE, when it comes into the build service, there's a community maintainer who's responsible for it. He's creating a package, and he will submit it to factory. That package will be vetted by a maintainer of the factory project, and before it goes into one of our distributions, it'll also go through a QA process. But the point is, there's somebody maintaining it all the way, and there's a bunch of chains of places where you can get this package from. Ultimately in the repository of the distribution itself, right? But along the way, maybe you're using an extended world of Python, and so you want to use the Python repository. But you have these packages that have been pre-built, they've been pre-compiled. Most of the time, they're running the test suite as part of building the package, so you know they work, and you know they're good, and you know they're safe. If you don't do this, things like this happen. How many people heard about my Node left tap right? This is a disaster. This guy pulled a package off Node. No enterprise distribution is packaging Node.js and supporting it. It's impossible. The Node architecture does not work. It's just not maintainable. I myself spent 6 weeks on a project trying to package one Node.js package in a supportable way. It had 150 dependencies, including 7 different versions of the one same package. Okay. So people rely on NPM and pull them into their Docker files. And when somebody pulls something off NPM and you're using these Docker files that are constructing the Docker images dynamically by pulling things from NPM, and somebody says, no, I'm taking my toys and going home, it all falls apart. Now, if you did this on infrastructure from a distribution, even if it's just some guy who's maintaining this in his home repository, you'd never know that ever happened because you have a package from a reliable source that's being tested and maintained in an official way. Right? So that doesn't happen to you. So now, the root of the problem, though, these are kind of ancillary problems. The root of the problem is that you want dev to match production. Right? You want to be able to get your dev environment as close to production as you can, but you don't want to have to use, like like Richard said, crappy old tools. So let's look, for example, let's say you're developing on Python. And I'm going to have to point because I can't go point with my fingers here. So Python 2 and Python 3, Ubuntu 6.04 just came out, 16.04 just came out like yesterday, right? And so there's a jump to a new version. And it's different than 14.04 LTS was. This is a minor version, you might be okay, but how do you know there's not some deprecations? This is a bigger jump, and I guarantee you that there's source code that'll run here that won't run here. Okay, so if your server is still on 14.4 and you're developing on 3.5.1, you're going to start having failures in your development environment that you didn't see in production. Okay, Fedora goes way far out. You know, Fedora says we're where Red Hat gets created. We're the origin. We're way out on the edge. We're doing new things that will eventually be in Red Hat. That's cool. That's a great way to work. But RHEL 7.2 doesn't even ship Python 3, right? And Python 3 has been out for
years.
2008?
Yep.
Yeah, 8 years, right? It's not shipped yet. They don't consider it enterprise stable. And there's even a big jump on the old version, which is moving across. So openSUSE Elite is an actively maintained distro. You're going to get fresh user tools annually.
Yep.
But everything underneath, all your support systems are coming straight from SLES. So they're the exact same versions in every case. So this is Python. You say, whatever, that's my thing. I can package that up some other way. But let's say you actually want to dev in this environment and you want to use modern tools. Like you want to use some IDE. And I just picked the freshest IDEs from both major desktops, GNOME Builder and Kdevelop. And this is where you see that it's really a problem. If you want to stick with like developing on the production environment, you don't get any IDEs in RHEL. The closest you'll get is like Vim, right? Ubuntu Server, same kind of deal. You get some older stuff in KDE. Why they have that package for Ubuntu Server is just because of the Ubuntu environment. That's the way it is. But you see this here down here too. We don't have these kind of packages in SLES. Userspace tools and an enterprise-grade distribution aren't there. But here we're getting fresh, happy userspace tools. 3.16 is roughly a year old.
Yep.
But with 4.2, we'll move to the new stable.
Yep.
So it'll probably be
14.2, we're aiming for
3.22.
Yep.
You know, 4.7, this will probably move to 5. But even Ubuntu is not shipping 5 yet for Kdevelop. So again, you get a nice match on your underlying stack. You get fresh user space tools. So the other side of this is the distribution lifecycle. And the question really is, how often do you want to rebuild everything? Because when you're going with this environment, when you get into developing like this, you're concerned with your source, right? How many of you want to go change your code every time there's an upstream change and stay on? Or how many of you are just going to like pick, we're at a point, this is working, this is what we want to stick with, we need to concentrate on our code, not what upstream is doing every other day, right? Everyone, yeah, okay. So this really comes down to how long is the distribution that you're using in production going to live for? Because when it goes end of life, then you don't have a choice. You need to catch your app up to whatever the current state is for stable. So Ubuntu says there's an LTS version every 2 years since 12.04, and each version will use 5 years of support. And what they mean for support is that there's comprehensive support for 2 years, and then there's maintenance support, bug patches for 3 more years. So you get a chart like this. And I'm just going to walk over here and say, you're running 14.04 now, because there's no way you've gone to 16.04 already, because it's going to take you a month to figure out what's different, right? So you're going to hit 16.04 sometime in here, maybe next year if you start now. You'll be ready to take your app. Okay, and then you have 1 more year of updates regularly, and then you go into maintenance mode. And so you get 2 more years. So realistically, you're probably getting 1, 2, 3 years out of that before you got to start thinking about changing again, even with a 5-year life cycle. That's good, but it could be better. And I'll leave aside the fact that you cannot just easily buy support if you have a problem from Ubuntu. You are in the community support only. Okay. Red Hat goes longer. Since 5, they're saying 10 years of support. and they have what these call these phase productions. So phase 1 is new hardware is being enabled, new features may be enabled. Phase 2 is if a customer is big enough to complain, we will add new hardware support. But mostly we're talking about bug patches. And phase 3 is when there's a patch, when there's some bug out there that gets a name brand and its own website, we will patch it. Right? So, Ghost, Badlock, Shell Shock, yes. Okay.
Good list
So,
of bad rock.
This is better. Now you got 10 years, right? So you're going from a community support, you're going to an environment where you can pay somebody, and there's an 800 number you can call, there's an email you can make, and when there's some problem underneath, somebody's gonna fix it for you. And that's, in a production setting, that means something, right? I know when I started developing, before I worked at SUSE, we devved in openSUSE and went to SLES on production because Murphy's Law. Something's gonna happen. And I swear, if there's something wrong with this kernel, I'm never ever touching it. Somebody's going to fix this for me. So now, and sorry, microphone, I'm stepping away. So it's 2015. You're on RHEL 5. Maybe you've already made a jump to RHEL 6. You're getting along support, but you've still got 5 years before you even have to think about it, right? That's a good runtime to be working on your app and not worrying about what's underneath. All you have to worry about your app. Everything underneath is going to stay binary compatible for that whole life, and just bugs are going to get fixed. That's better, right? Does anybody prefer to be going back and rewriting their whole app every 3 years instead of 5? No? Okay, well, we think we're doing it better, and it's real simple. All SUSE products are supported up to 13 years, and the 13 years definitely applies to SLES. So this is what SLES 12 is going to look like, and this was, when did we go GA? November 2011, right?
No.
No.
GA was last year.
No.
No, GA was the year before last. SP1
Yes.
was last year. SP2 was this year.
14.
Yeah, 14.
So you moved to SLES 12 sometime in 2015, and we'll give you service packs, and service packs will maintain compatibility for any app that depends on it, right? And you can migrate through service packs. Service packs will enhance hardware support, so you can move to new machines if you want, support new VMs. And then when we finally get way down the line here, 6 years later, then we will just do bug fixes. And then LTSS is name brand patches only,
Yeah,
right?
it's like, if you want to pay us a huge pile of money, we'll also do the LTSS for each service pack.
But this over here, this is 2024. Okay? You might not even be doing this job anymore. You might not even be maintaining that code base, right? But in the meantime, you spent all that time worrying about your app and not what was underneath it. That's cool, right? Right? No? Anybody think that's horrible? That sucks. Yes.
So what happens when you need to move on to the next version and you've got 13 years of patches to go through to update your software as opposed to doing a little bit at a time?
When you move on to a next version, you will be able to move on from any of those service packs, and that new version will come out right about here. So you'll have a good 5 years to figure out that move.
And we test that kind of stuff heavily. Like, we're doing like N+1 migrations already, so you can jump from like GA to SP2. In fact, you can jump from 11 to the previous major version straight to 12 SP2. All that kind of version magic. We're taking care of that at the base level. So if we can do that, your application shouldn't be too hard to rebase on top of that.
Yeah. We're doing this in like Amazon too now.
Yeah, cool.
Yep. Yeah. So, which was not fun to figure out because they didn't want to let us do it.
Yeah, they think we're nuts, but it works.
Yeah. So, apples to apples comparison. This is how long new hardware gets enabled on what I would consider a long-term supported distribution, how long you'll get critical updates, and how long you can buy extended support for. And extended support is, again, still, I have an 800 number to call. I have somebody who has a legal contractual obligation to fix my bug, period. So, and now I'll hand it over to Richard.
So,
use the arrows.
Yeah, we've got the problem. We've got a bit of a solution when it comes to the production environment, but we haven't really talked about the dev stuff. Who here is using openSUSE for anything at the moment? Few of you. Okay, good. So most of you don't know, need to know this anyway, but we're openSUSE. It's an open source community project sponsored by SUSE. So we do our own thing. Yes, we do lots of things with SUSE too, because many of us are employed by them. But it's a totally open community. We have lots of contributors who aren't working for SUSE. We were founded in 2005. Our official mission is promoting the use of Linux everywhere. And we make, well, lots of things, including 2 distributions. So this means we're 10 years old. I have to fit at least one cat picture in all my slides. So there we go.
He snuck it by. Wanted dog pics.
Sorry. So yeah, 10 years old. In fact, August this year will be 11. So yeah, we're doing quite well. We know this stuff. We've been doing it for a long time. And when it came to putting this slide deck together, it's like, what are we actually doing? Like, everyone knows this is like openSUSE as a distribution, but it's a whole ecosystem now. In fact, we haven't just got one distribution. I mean, we're here talking about Leap, but we've also got Tumbleweed, our rolling distribution, which is much more for the bleeding edge, I don't know, upstream developer, the guy who wants to be that close to upstream all of the time. You know, we have Tumbleweed rolling with all of those upstream packages. We're faster than Ubuntu. We're faster than any of the other rolling distributions. Faster than Arch. And yet we're more stable because we actually have OpenQA, the testing system that we use for Leap and for SLE and for Tumbleweed. So we have this kind of reliable rolling release that lets us really move this stuff quickly. We've got Snapper, we have Wicked, we have the build service. So we have this whole ecosystem of stuff. And a few years ago, we kind of started sitting around and thinking, okay, like, what's next? Like, we're doing all this cool stuff, we have our distribution, we've got quite a lot of users, but, you know, where do we go from here? And so, as we were sitting around talking about it, we realized that the old-fashioned openSUSE distribution, the Fedora equivalent or the Ubuntu equivalent, was being pulled in 2 different directions. We had a whole bunch of users that were like, okay, we want more new stuff. We want everything to be fast. We want to be more like Arch. We want to be more like Gentoo. Like, just give me the latest of everything. And at the same time, an equal number, like, we want more stable. Like, we want an answer to the developer issues. We want an answer to this like dev production paradigm. We need that too. In
a room full of 20 people who are openSUSE users, 10 of them would say that 8 months was way too long between releases, and 10 of them would say 8 months was way too short. They don't want to upgrade the computers that often.
And this really was pulling us apart. But then of course, yeah, we've got Tumbleweed now. That's our rolling release. That covers the speed thing. Done. We've got that. If you want a fast rolling distribution, Tumbleweed's where it's at. So
he updated his Tumbleweed on his laptop this morning,
yeah,
just to make a point of
like new updates this morning. Roll them, put them on there, fine, everything's working. In fact, this is working better than it did yesterday because that was rendering a little bit wrong. So we're fixing bugs every day with this stuff.
Yeah.
You fixed like the NVIDIA problem.
Which NVIDIA problem? Yeah. I mean, we can't fix NVIDIA like totally because they're just broken. But yeah, we get quite a few NVIDIA drivers fixed in there as well.
NVIDIA on Tumbleweed, NVIDIA from NVIDIA on Tumbleweed is harder.
NVIDIA,
you're probably going to get 4 kernels a week.
Okay.
Yeah. Yeah. So I actually run all the open source drivers on all my Tumbleweed machines, and I live with it.
So it works fine with like Mesa?
Yeah.
Oh, okay.
No problem at all. You can do the proprietary drivers, but like you have to put like DKMS in there and get that stuff working. So, yeah. Anyway, back to like thinking of a stable release. So, like, what makes a perfect stable distribution? Like, not just the one that deals with the dev and production issue, but you know, just generally speaking, you know, you want it to be stable. You need it to be well maintained, and ideally, you want it to have like an enterprise basis, and you wanted to have some kind of parity with that production environment where you're going to be putting this stuff. That means you want to have a life cycle of at least 3 years. I mean, probably a little bit longer than that, but you know, as a bare minimum, you'd want to have that version of that distribution there for at least 3 years. It's got to have a wide selection of packages, or to put it another way, it has to have that modern, relevant user space tools for what you want to use as a user and what you need to do as a dev. And so, I mean, we spent a fair bit of time talking about this. There was lots of antagonizing within the community, like, okay, how the heck do we do this? We had the Evergreen project, which was like a community spun up LTS equivalent, which kind of proved the concept in some sense. That kind of ticked off the stable bit, kind of did the well-maintained part, but yeah, lifecycle was kind of like whatever the hell the maintainers would decide that day. So, like we had one version that lasted 6 years, one that lasted 4. It's like, yeah, okay, whatever. wide selection of packages, yeah, but as time goes on, it's really hard to maintain that wide selection of packages. It's tough to keep it all moving, especially when upstreams go and do crazy jumps and you've got to deal with that backport. So internally at SUSE, a bunch of us openSUSE guys started talking to management about what if we took the SLE source code and used it? The SLE source code is open source, but in the same kind of vein as Red Hat, it wasn't the easiest source code to get your hands on. If you request it, you get all the disks, but you've got the disks, you're dealing with all the media. We have our build service, we have all this stuff automated. We're used to just nice, simple, click a link, give me a spec file, done, yeah. So internally, we started talking about that. And actually, SUSE were actually, that doesn't sound like a bad idea. In fact, we originally started asking for a bit of the source code, and they're well, why not just have the whole bloody lot? So we were able to basically take the whole of SUSE Linux Enterprise, almost, take all of openSUSE and put it together and make openSUSE Leap. And the reason we were able to sell this, not just in a sort of benefiting the whole world and benefiting our community, but we realized also it benefits SUSE. We have a situation now with Leap where openSUSE has a much more stable code base for this kind of use case, when you need to be doing proper work on a community distribution. On the flip side, SUSE have a much easier way of actually getting an upstream innovation, because openSUSE is suddenly more relevant for them. Some community crazy thing running on Leap suddenly is really quite easy to shove in SLE for the next service pack. And you saw how those service packs are iterating every year. There's quite a lot of checkpoints where they can start adopting stuff. So they see the business benefit out of that. And of course, from both sides, we have improved collaboration. We're talking a lot more. Our community's a lot more engaged with what the business side's doing. So it just makes sense. It's the traditional open source model, but in a way embraced more strongly than most companies actually go in for. There's always that kind of proprietary line of, you don't want to go there. SUSE's jumped right over it, and it's really helping them out. So, thinking of the whole family, we now have a situation like this. We've got Tumbleweed on the far side there, all community developed, rolling like crazy, everything moves. On here we have SUSE Linux Enterprise, developed by SLE, and there is a shared core in between. It's not a one-for-one match, because to make Leap, we basically take, I'd say over 6,000 packages, all of that user space stuff, and get it running on top of that shared core. Sometimes that means having to shift a few things around in order to make this actually work. So there's a few times, Mesa versions, for example, one example where we bumped that up a little bit in 42.1, away from the SLE version, so we could get latest KDE running on there. So that means we're then maintaining that as a community thing, separate from the main enterprise stuff. But generally speaking, the default is the shared core, and we're just now starting off the development for 42.2, the second iteration of Leap, and we're seeing this kind of gap here shrinking already, because the crazy stuff we did here in Leap is now the stuff they want in SP2 for SLE 12, because we proved it works, and it's less work for them to do. So yeah, we can take that step forward when the community needs it, when there's a nice technical case for it, and then it actually helps the enterprise side accelerate their development way beyond what they used to do. And yeah, it means that our life cycle ends up with a really nice complicated graph. Because basically Leap and SLE develop themselves in parallel now. There's a shared core in between. When SLE development kicks off, this shared core appears in the build service about the time this is beta quality. So SLE 12 SP2 should be beta in a couple of weeks, yep. And that's when Leap development will kick off. In the openSUSE build service, we'll have this core.
I think the core is already there.
No, the core's not. We've started this part in the build service, but we haven't actually got the core yet. So we're building, at the moment, we're building Leap 42.2 on the core of 12.1, and then we'll mesh everything up in a few weeks' time when we've got our hands on the SLE sources. So just giving ourselves a bit of a head start. Yeah, so developed on the same core, using the same base libraries, using the same kernel, and actually the same version of everything we can get away with. And then upgrading what we need, when we need, from our community, from our developers, from people who say, okay, we need this for whatever, And the easiest for us is, of course, if it's already in Tumbleweed, we can just selectively cherry pick that stuff out and take it straight into Leap. And that works incredibly well. Or, as in the, now we're at 42.2, we're also sort of, forward porting stuff from Leap 42.1. So, if it was good enough there, we don't need to necessarily move it up to the latest and greatest. That'll be the version in 42.2. So, kind of keeping that kind of parity, but making sure that things are still there, fresh, relevant, consistent, moving along. And this will carry on for 42.2, 42.3, and probably around about the time of 42.4, SLE 13 will kick off. And that's when we will start working on 43 with that same base system. Now, in the case of the SLE 13 base system, that is going to be entirely based on Tumbleweed. So the Tumbleweed rolling release process has proven itself well enough now that an enterprise distribution is like, yeah, okay, we'll just take that. And okay, admittedly, they'll take it and wait 6 months until they start shipping something on it, because enterprise stuff takes a bit of polish. But yeah, we're no longer doing the old traditional kind of factory going to openSUSE going into an enterprise distribution, or the Fedora rawhide to Fedora releases to RHEL. It's just skipping straight past that and going into SLE 13, and we'll have 43. So that actually ends up meaning that the lifecycle will continue on. We're not planning on carrying on 42 releases after that. So there's admittedly there is a tendency here to kind of encourage development on the latest version of SLE. So you can run it in production on SLE for 15 years. But with Leap, we were kind of aiming for the 3, 4, 5 years of active development. That kind of the heavy support period where everything's being fixed everywhere and no extended support, all that kind of stuff. So it's 3 to 5 years or so. And we think that's actually answered all the questions. We think we now have, we know we have a stable distribution. We know it's well maintained. A perfect example would be Badlock, where Badlock was patched in SLE in the middle of the night because it was, everything's on fire and everyone's screaming. That was shipped to SLE customers. By 9 a.m. in the morning, that was shipped to Leap users. And for Tumbleweed users, it took us like another day because, sometimes doing a rolling release is hard. So, yeah. Different version, rebasing a whole bunch of other crazy stuff that moved at the same time. Yeah, we got it out there, but, this is well maintained. This really works. It has an enterprise-based system. It has that parity and that constant ongoing relationship with that enterprise distribution for your production environments. That means 3 years plus. If we'd started it when 12GA started, that would be like 4 years plus. But we started this a little bit late in the game for that. We've got our wide selection of packages, say 8,000 or so right now. There's no limit to that. I mean, if people are willing to submit packages to the build service, we want more. We're happy to have them. We're happy to have more maintainers. We're an open project. That's what we do. And so we have that modern user space for developers and users. And that's my last slide. So any questions? Yes?
Yeah, I went to Tumbleweed on my personal laptop
Cool.
because I was tired of doing all of the installs every so often.
Yep.
Now I've got a bunch of users I support, and right now I'm on 13.x. I'm thinking about taking it to 42.1.
Yeah.
I assume that's going to be a complete reinstall.
No, you can upgrade from that.
You can.
You can.
And
You
then
can.
same thing from 42 to 43. It'll just be
Yep.
a zipper update.
Yep.
Okay.
You can even do 43 to Tumbleweed, and in fact, you can even do it backwards. So,
Yeah.
yeah. So yeah, all that stuff's fine. No reinstalls required. We've even tried. This is experimental. We have tried SLE to Leap. So start with the SLE machine, add the Leap repositories, zip it up. It's worked in every test I've run. But yeah, for 42.2, we're thinking about maybe making that fully supported. We just need to see how bad it is when we start playing with it. Yes.
So if you want the more stable system and you're on Leap, and then you want like 1 or 2 bleeding edge packages for doing development stuff, is
Yep.
that where the build service comes in then?
That's where the build
That would
service
be
comes in.
like
Okay.
the devel repositories in the build service.
Okay.
Yeah.
So that's, or the factory repositories, which are what feed Tumbleweed. So, and those are very granular and topical. For example, there's devel languages Python, and you can say, yes, there are these 2 packages that I need fresher, so I will subscribe to those 2 packages from developing Python and deal with just that outside of it as an exception.
Great,
Yeah.
thank you.
Yeah. But I mean, SLE also has it depending on how bleeding you're going. SLE also had its module concept, so that it's got effectively its own moderated, mandated repositories for that kind of stuff. A lot of that has parity with what's already in Leap and other projects. So yeah, we're mixing and matching all that stuff quite easily.
And then Package Hub is kind of coming along slowly, which will allow third parties and more stuff from the build service to be available for SLE and in SLE. So that's kind of still a work in progress.
Yeah.
There's a challenge there because I'll put on my SUSE hat for a sec.
Yep.
We have to.
Yeah.
So when I mentioned supported, and I mentioned somebody has to fix this. You know, we have what we call level 3 support, and level 3 support is that your solution, your problem will be resolved at an engineering level, and you will have a package that fixes the issue that you have, provided by a SUSE engineer or an upstream engineer if it's a more common issue. But I mean, that's how far it goes. So there's a finite scope to how many packages we can do, and we're growing as fast as we can. There's like 100 open jobs at SUSE right now because we want to do more, and the bigger we get, the more packages we support, and the better it gets. But yeah, so there's a finite amount that we can support there, and that's where that blue line is. And the decision is generally around, this is a server, this isn't necessarily a desktop machine, this isn't necessarily a dev workstation, so all that user space stuff is the first thing that gets left out,
Pretty much.
which is all the stuff that you actually want to use when you're developing.
Will there be a server version of Leap available?
Leap makes a good server.
Leap makes it, yeah. So the installer for Leap 42.1 has a server option, but it's hidden away under other. So you get the 2 desktop options and others there. In Tumbleweed already, and of course in 42.2, it's now a big clear box, so people don't ask that question. Yeah, we don't prescribe to the kind of additions model like Fedora or Ubuntu, where like everything is just another spin. It's good for marketing, but it's not good engineering. And so there is one Leap, and then you can use it as a server, and it'll work perfectly fine.
We haven't
strip away all the dirty crap.
Exactly.
No, you do it like a text mode,
Okay.
or through SUSE Studio. You
Yeah.
base it on the juice image or the text mode image, the server image, and you start from there. And we have like kind of the other problem with remixes because there's like 15,000 respins on SUSE Studio, so it's not like there's the Fedora spin. I mean the KDE spin and the this spin. It's like there's too many spins. So
we are thinking of doing very tiny userspace image, JEOS, so just for like VMs and stuff. But that'll really be no different than the minimal installation. It's just we've done it for you and popped out the images. So yeah, we already have them in the build service.
yeah,
Yeah.
or you can, and through Studio, that's like 6 clicks to make it produce a
Yeah,
juice
true.
image for.
Yeah, my one's
VMware or
tested
Amazon.
though. Yeah, I put mine in
Fine.
the QA. But yeah, usually does that too.
So is there a hardened open leap image or an option?
Hardened? What would you like to be hardened?
Just generally security hardened, like I'm going to put this on the internet.
Out the box.
SE Linux type hardening.
Well, okay, so we do have SE Linux support in Leap. We
Okay.
prefer AppArmor.
Okay.
AppArmor's actually on the default install out the box,
I see.
done
Okay.
with our profiles. So, yeah, if you want to go the SE Linux route and you have your profiles you want to use, just flick on the package, done. Yeah.
There's also the YAST hardening
Yeah.
module.
There is also the YAST hardening module, which has pretty sane out-of-the-box defaults, but it's a simple case of going to YAST and you get this very nice interface where you can do a lot of hardening in there as well. The firewall's turned on out the box, so that's pretty strict. So we try and best to kind of be secure out of the box, and then if you've got, this is of course coming from kind of the SLE heritage, if you have like a strict regulatory environment, you know what the requirements are, you bump it up to there. Yeah, and actually that's worth mentioning is like, or even for all this shared core, and therefore the sources are the same, the spec files are the same, the certifications aren't actually, inherited. So from a practical perspective, it's fine. But Leap doesn't have the certificate, the FIP certification. SLE does.
Yeah.
And we're not aiming to fix that. It's not worth the paperwork.
Any more questions?
All right. Cool. Well, if you want a Leap sticker, there's a pile of them at the front here, so for your laptop. And
There might be a few T-shirts at the booth still.
And there should be some T-shirts at the booth. We're over in the Haskell building. Just we've got a nice little lounge there with our stuff. Thank you very much.
No, it's still there.
This is a nice
Radio Shack, whatever.
Yep.
Thanks, Ryan.